Recording started. Um, okay, let's start on the instrument transformer. So the instrument transformer is basically, it is not supposed to deliver power or to power up the devices. It's just like used for measurement purposes. It's not consuming power. And we are using like these two examples like VT and CT. VT, which is the voltage transformer that's converting high voltage system to a standardized level like 110 volts that's suitable for measurement and protection. The same thing for the current transformer, which is basically reduce the current to 1 amps or 5 amps to maintain a safe and accurate monitoring. The reason why we are using this, we don't want to um, for the SCADA system or the protection system, we don't want to get 132 kilovolts input voltage or 635 input like 635 ampere input as an input current. This will be very dangerous, will damage the equipment. Therefore, we are using CT and VT to convert them to a lower value by scaling down the voltage level and the current level. Then they can be safe level for measurements and protection as well. And again, the reason why, what's the point of measuring the voltage and the currents? We are using them for monitoring the operation condition and the fault condition. If there's something wrong happening, then the protection equipment will work. Then how can the protection equipment will work if there is overcurrents or over voltage by using CTs and VTs. The other thing, the transformer or the CT and VT will transform the voltage and the currents to a low level. They can be easy to or they can be measurable, so they will not impact or they will not harm the protection systems. So the again, like the protection systems or the overall protection and the measurement systems, when we use CT and VT, we will reduce the overall cost because we don't want to make a protection that can measure 132 kilovolts or a protection or a relay that can measure 600 amps. While when we are doing CT and VT, we are scaling them down, then we are reducing the overall costs. Look at this picture here. You will see two pictures. Those are CT, CT and CT. So the CT can be distinguished by seeing this top. This is a top, this means a CT. When you see this top like a cylindrical shape, this is a CT as well. Then the CT again is used to measure the currents, as we see here in this picture. Again, this is another picture from Jordan substations. This is CT, this is a CT. You can see there is a CT for each phase. Each phase has a CT, therefore we should have three phases. Then here, like this picture as well, this is a CT, CT, CT. How about VT? The VT looks like this one. This is a VT, VT, VT. This is VT as well. This is a VT. So VT, voltage transformer, like this way, while the CT, you see the top, the cylindrical shape here at the top, this means it's a CT. Okay? So you need to distinguish where is the CT, where is a VT, the VT by looking at just like the equipment. So, I mean, if you go to the substation, if you travel to substation, like do a visits, 132 kilovolt to 33 kilovolt substation, you should be able to distinguish where is the CT and where is the VT. Here is again the picture. This is those, when you look at those equipments, this is VT. No, I believe no. This is it's called surge arresters. While here is a CT. This is a CT. This is a VT. So CT, current transformer. This is VT. While these equipments called surge arresters. Surge arresters for lightning strike purposes. Okay, when you look at this one, you will see three surge arresters. But there is something, a device that's kind of different than the other phases. When you compare 1, 2, 3, this device is different. This device is called line trap. What's line trap? Recall the Earth in when we discussed in the previous chapter, the Earth wire. we said that the earth wire, there is the regular earth wire, and we said there is OPGW, which is the optical ground wire. We said OPGW is used for communication, and it is used in new power lines. While the regular one, it was on old power lines. So now the question is, in old power lines, what was the communication channel since there is no OPGW, there is no fiber optics? The thing about it, we use the power line for communication. So for example, use this power line for communication. Use, again, power line in communication. How? As we know, the power line has a standard waveform, for example, like cosine 2 pi times 50 hertz, pi t, which is times 2 pi times the frequency, which is 50 hertz. Then we can put the communication signal inside it. With high frequency components. So we can say the black, which is the communication signal, while the blue is the power signal. You can see that the communication signal has low power, low energy, while the power signal is called power signal, which has high energy. And the other thing, the communication signal with high frequency, while the power signal is used for low frequency, which is 50 hertz. It's very similar to FM radio, which is using a channel with a constant frequency. Then you can put the carrier message signal like this. Then when you, in this phase, it will be one of the phases. For example, here is phase B, has two components, power signal and communication signal. Now, when we reach the substation, we need to distinguish which one is the communication, which one is the power. And we need to get useful information for the power signal. Therefore, the line trap is basically a low-pass filter. This is a line trap. Then you can take the output is the power, and take another output goes down to the substation, which is the communication. So this will go to the SCADA system, while the power will go to where the transformer, to the bus bar and the transformer, etc. Then the line trap again, which is a low-pass filter that will split the signal to be a power signal and communication signal. And it is used only in old electrical substation and old power lines. Nowadays, in the modern power lines, there is no need for the line trap. We are using the OPGW, and that's it. Okay, so this is very important. You see, the line trap is like a cylinder. I mean, a cylinder here, you see? This is the line trap. It's only on one phase, not in all of the phases. And again, it is used to distinguish and like separates the line between the power and the communication signal. Again, CT and VT are used for sensing and monitoring. Why? What's the point of measurements? For protection, billing, and monitoring. Here is the VT potential transformer. Again, it means VT. This is the VT, how it looks like again. This is how the VT inside. This is picture, so now we're going like to several pictures. This is the VT as well, but it's used in very high value. This is used for 400 kilovolt in extra high voltage. This is a VT, and it can be used for double circuits. It can be used for bundled conductor when we have two conductors. This is the working principle for the CT, whereas like the current is flowing. Then since the current flowing according to right thumb rule, there will be flux going on here. Then the flux will produce a current to the ammeter, then we'll give the measurements. So the good thing about it, there is no need to disconnect the wire or to cut the wire for measurement purposes. Just use this clamp or this, we call it CT, to produce the currents. Here's how the CT looks like. You see like at the top, there's like a cylindrical shape. That's how we distinguish this CT by the cylindrical shape. Sorry. This is the lab CT. In the lab, well, like when you go to like the power lab or power electronics lab, machines lab, you might see these clamps that can be used for current measurements. The good thing about this current measurements clamps, there is no need to cut the wire. Just like put the clamp around the wire, then it will do the measurements. Here's again the CT, how it looks like. Look at the cylindrical shape again. As I said, like in the power systems, you will see it like a cylindrical shape. Now, the other thing, ground transformer, which is known as auxiliary transformer, zigzag transformer. It has three names: grounding transformer, zigzag transformer, and auxiliary transformer. And we already discussed this before. This thing about it will provide the neutral points for the power transformer. That's the first purpose. Neutral point, which is very important. Why? That's why we have the grounding transformer or zigzag. And the other thing will produce power to the substation for essential services such as lighting, heating, cooling, battery charging, etc. And it is called zigzag. Why it's called zigzag? It's special type of why, but it will just like to produce a grounded and there's to produce a neutral. This is how it looks like, the zigzag, and produce it's connected, the neutral connected to the ground to provide the grounded and neutral. Then the other thing, when you look at it, do you remember this from the signal single line diagram from the substation? This is, I think, from North Amman substation. I believe it's from North Amman, whatever. Then when you look at it, we already discussed this before. We said TR1, which is 132 kilovolt to 33 kilovolt, this is a power transformer. While when you look at ETR1, I said before, do you remember that? We said this is the auxiliary transformer. Or we can say this is the zigzag transformer. Okay, so whatever you want to call it, auxiliary or zigzag, or you want to call it the grounding transformer, all of them, they are the same, which is the main reason for that, to supply power to the substation and provide the neutral points for that transformer. Okay? This is how the zigzag transformer looks like in real life. You see it's a small transformer which will be very close to the power transformer. Here's another picture. This is the power transformer. This is the zigzag transformer. Okay? A small one. Here is another clear image. You see this is from North Amman substation as well. This is, I took it by myself when I was with NIPCO. Then this is the power transformer, PT. This small one, this is the zigzag transformer. Okay? So it's very important when you look at it to distinguish where is the zigzag transformer, where is the power transformer. Okay, how about this one? This is a CT for each phase. CT, CT. How about this one? VT, VT, VT. Okay? So from this picture, you should be capable, or you should be able to distinguish, or there are four types of transformers are in this picture. The first one, the power transformer. The second one, the zigzag. Third one is the current transformer. And the fourth one, which is the voltage transformer. Okay? Then you need to make sure to distinguish where is the VT, where is the CT, where is the zigzag, and where is the PT power transformer by looking at the picture. And when you go into the field, you should be capable, you should be able, should be capable of determining or understanding which the type of the transformer. Okay, so again, the power transformer, which is the largest one or the biggest one, again, why it's big? Because it has a very high ratings here, for example, like 60 megavolt ampere, while the zigzag transformer has a very low value. That's why it's smaller. Well, again, CT and VT are very small instruments because it's just like used for measurement purposes, not to power up the devices. That's why they are very small. Now, the main components of the transformer, there is the iron core. So the core, which is constructed from the thin laminated of silicon steel, and which is tightly stacked and securely clamped together to form a rigid magnetic path. And the thickness, which is very thin, 0.3 to 0.5 millimeters. And the insulation, it's very insulated from each other using varnished or insulated papers to minimize the eddy current losses. Then the silicon contents inside the steel will improve the magnetic permeability and reducing the hysteresis losses. This is, the iron core, how it looks like. You see like there are a lot of shells and they're stacked together to form a core. Then when you look at it, there are two types. There is a shell type and there is the core type. Then the shell type, you see like it is outer and the inner, which is the coil inner. Coil is inner. While the core type, the coil is out. Then you need, when you look at the shape, you need to distinguish which one is shell type, which one is core type. This example shows that this is again the core type, like this one is a core, this one is a shell. When you see the core outer of the coil, then which is it will be shell. If the core, or if the core is inside while the coils is outside, then it will be basically core. Here is an example. Look at this picture. So you will see the right. This is called shell type because the core is outside. Here the core is inside. Then it's called core type. Okay. Now, when you look at the three-phase transformer, this is core type because it's inside. This is how the core type looks like. And this is the shell type. This is how it looks like. The coil are inside. Okay? Again, you need to distinguish between the shell type and the core type. This is a core. This is a shell. How about this one? Is this shell or core? Look at the coil. The coil is inside. This is a single phase, by the way. Since it's inside, then it will be basically shell. Because the core is inside shell. Core is outside core. Or the coil. Then how about this one? Is this shell or core? Look at the coil. Coil outside. So it is definitely core. Here, this one is also core, but we just like to let you know about the windings. So when you look at the windings, you will see the low voltage inside, the high voltage outside. While the high voltage outside, when we look at the coil. Then the other thing you can say, if it's step-down transformer, so the primary, the secondary is inside, the primary is outside. If step down. So the thing about it, keep the lower voltage side inside, the outer voltage, the high voltage side outside. Because as we know in the transformer, there is a high voltage side and there is a low voltage side. Then when you do the winding in real life application, that's how we're doing it. Again, the primary winding, which is basically the high voltage side, will be outside, or while the secondary winding, which is basically the low voltage side or toward the load, which will be inside. That's the thing that we need to think about. The connection terminals, which is basically that's used to connect the winding terminals from high voltage to low voltage, as I said. Then when the transformer is connected using underground cables, the terminal box is installed on the side of the transformer. While when the transformer is connected directly to the overhead transmission line or bus bar, the terminal will be mounted in the transformer cover. So that's the thing that we need to think about if it is based on underground cables or if it's based on overhead transmission lines. Insulation materials. So one of the insulation materials that are in the transformer are called the bushing. Let me show you one picture of the transformer, like the power transformer, then we can let you know. So look at this one. There are bushings here. 1, 2, 3 bushings for each phase. When you look at these bushings, these are the bushings. They should, they will carry the cable to go inside toward the core. The same thing here, toward the core. So it will go inside the main tank of the transformer or the main frame of the transformer. So they will go inside. Again, those are called bushing. Those are not the same as insulator. They are different. I mean, the insulator that we are using in the power line, as we discussed in the last lecture or the last week, they are very different than those. Just like a solid, they are bushing. They are called again bushing. And the winding, or like the bushing, you will see the cable or the conductor goes in and it's mounted inside. Then it will keep going inside until reaching the core. The thing about it, again, it is mounted inside the transformer. So for isolation, so we don't want that cable to conduct with the frame of the transformer, the main frame. And it has some insulation inside it, made from porcelain, and there's some oil inside for insulation as well. So again, they will connect the windings with the electrical power supply using the terminals through the bushings. Then the bushings must provide a proper insulation and separation between the windings and the main tank. So we don't want the main tank, or we call it the big frame of the transformer. We don't want this to be electrical conducted. Then this will provide an insulation. So bushing classifications, there is air to oil bushings, as we said here. There's air to oil, there's some oil insulation. And there is another type, which is air to SF6 bushings. So there is no oil where there's gas SF6. The other thing, according to the construction, there is a solid bushing, as we see in the previous slide, and there's capacitance graded bushing. Then according to the internal insulation type, there is air insulated bushing, oil insulated or oil-filled bushing. There is oil impregnated paper insulation bushing, and there is resin bonded or resin impregnated paper insulated bushing. There is cast insulation bushing and gas insulated bushing. There are here like different types of bushings, as we see here. Those can be used different voltage levels, different types, but the bigger bushing, the higher voltage. That's the thing that you need to keep in mind. Tap changer. Now, of course, I think you already heard of tap changer before, but what's the point of the tap changer? Which is basically to increase the voltage and decrease the voltage. But the voltage has already been determined, right? I mean, we already have 132 kilovolts. That's converting to 33 kilovolts. Okay, so what's the point of adding tap changer? We already have this. So sometimes under light load condition, there will be a low consumption of reactive power. Since there is a low consumption of reactive power, the power line will be capacitive. It's capacitive. Since it's capacitive, it will make Ferranti effects, which is basically 33 kilovolts will no longer be 33, it will be 34 kilovolts, or sometimes 34.5 kilovolts. Therefore, this is very high value. We need to reduce it. How to reduce it? By adjusting the turns ratio. Adjust the turns ratio, then scale it down. Then it will be adjusted, then it will be 33 kilovolts back. It will back to be 33 kilovolts. That's under light load. How about under heavy load? Under heavy load, what's happening? There will be high consumption, high reactive power consumption. Since there is high reactive power consumption, this will cause inductive effects. The inductive effects will make it lagging, which is decreasing the power factor and decreasing the voltage. How to increase the voltage? By the voltage will be, for example, instead of being 33 kilovolt, it might reach to be 31 kilovolts. How to increase it? Increase it by adjusting the turns ratio. Now the thing, how to adjust the turns ratio? Using the tap changer. So the tap changer is used to adjust the turns ratio between the primary and the secondary. So if there is any changing in the output voltage side, it will take care of it. And this is very, of course, exists everywhere in all of the transformers. It can be either in power transformer or distribution transformer. Whatever transformers, it can be used. But the thing about it, there is something we call it online tap changer and offload, or onload and offload. We'll talk about it now, but let's keep discussing about the tap changer. So as we know, the transformer is expected to provide a constant output voltage, regardless the variation of the load or the supply voltage. To achieve this, because there's a load variation, it will cause a voltage variation. Therefore, we need to adjust the turns ratio to maintain a constant output voltage. So again, the main function of the tap changer is to regulate the output voltage to make it constant. We need to make it 33 kilovolts. We don't want it to be 31 or 35, so just make it 33. So how to do that? We will put the some taps, and they will be added at the primary side or at the high voltage side. Why they will be at the high voltage side? Because at the high voltage side, it will be easy to switch, and there will be a small variation because the number of turns on the high voltage side will be higher than the low voltage side. Then we have a small variation. We don't have a big variation, therefore put it at the high voltage side. However, if you put it at the low voltage side, any small variation can make a big change. While we don't want to make a big change, our target is to make a lot, just like a small big change. Therefore, we will put it at the primary side. While if you put at the secondary side, it can, for example, can be significant. Can be challenging. So again, the tap changer connected to the high voltage side windings, as I said, the current in the high voltage side is low. Therefore, the switching is easy. That's one advantage. The other thing, the change in magnetic flux is minimum. The high voltage side, as I said, has a larger number of turns. Then the location of the high voltage windings near to the core make it more convenient for modifying the transfer ratio. So for all of these four reasons, there is not only one reason, four reasons. Again, the first reason, the current is lower compared with the low voltage side. The second thing, the change in magnetic flux will be minimum. The second or the third thing, which is high voltage winding contains larger number of turns. And the fourth thing, which is the location of the high voltage windings near to the core, make it more convenient. Okay, types of the tap changer. As I said before, there is something we call it offload and onload or online. Offload, which is basically, it's very common in distribution transformers, and it can be in either low voltage and medium voltage. But I would say it's more common in low voltage. More common here. So the thing about it, we will do several study and adjust it, keep it fixed. It will not be changed depending on the load. It just being disconnected, and then if you need to change the tap position, you need to send a technician to do that. So you cannot do it by yourself, or you cannot do it automatically or computerized. You just do it technically. So the offload is being used and is capable distribution transformer around 20 to 30 kilovolt as well. Is capable of handling currents 10, 30 to 60 amps. It provides 3 to 7 tap positions. But the thing about it, again, what's happening in the distribution transformer, for example, 33 kilovolts, 2.4 kilovolts, the department or the distribution company will do several studies about the loads. If there is a heavy load, they will go and adjust the position. They will adjust the position here. Adjust the position, and that's it. They will not readjust it late. Just adjust it and keep it forever. However, if, for example, they see a behavior where there is a light load, if they notice that there is a light load, there is not much load here, then they will go and adjust it to be a light load. Adjusted the tap changer to be a light load. How can they know that? By the customer compliance. So the customers, they can file a compliance and say, the voltage that I have at home is 250 volts. It's not 230. Then they will file a complaint. So what's happening? The power company or the utility, they will go to your home and measure the voltage. When they see the voltage is 250, oh, it's too much. Since it's too much, they will go to the transformer and adjust the turns ratio by lowering the voltage level. Then they will lower the voltage level for you. Okay? This is very common, and we can see it a lot nowadays. If, for example, the voltage that you receive at home is 190 volts, it's not 230, then you can file a complaint, and then the power company, the utility, they will come to your home, do the measurement purposes at home. Then once they see the voltage is very low, 190 is very low, it's not 230, then therefore they will go to the transformer and adjust it to increase the voltage. Okay? This is called offload. So they will do it manually. They will send the technician, they will do the change the tap based on the load, based on the situation. And once they change it, it will be fixed forever until the next change. While here's, again, the tap changer, the distribution transformer. And they just do the switch. Here's the switch, just do the rotate the knob. And here how it looks like in real life. So once they rotate it, it will be shifted here or shifted here. Those are positions to increase and decrease the turns ratio. Here is again how it looks like. You see the tap changer is connected to the turns ratio, increase the number of turns or decrease it. This is how it looks like. Now, on-load tap changer, this is different. The on-load tap changer is basically used in extra high voltage, and medium voltage as well. The medium voltage, like the transformer, 33 kilovolts to 11 kilovolts, and high voltage, the transformer, 132 kilovolts to 33 kilovolts, and extra high voltage for the transformer 400 kilovolts to 132 kilovolts. Those the ones that we have in Jordan. Then those all of them are on load. What do I mean by on load? It is automatically increase and decrease the step size. It has the capability of monitoring the voltage. Once we see the voltage is getting reduced and reduced and reduced, this means there is a heavy load. Then the tap changer starts to be working to maintain the voltage level as 33 kilovolts. The voltage reduces more, which means there is more heavier load. Then the tap changer increasing the voltage as well, and so on. That's the on load. If there is a light load, then the voltage is high, like 35 kilovolts, then it's automatically decreasing the voltage, fixing the turns ratio to decrease the voltage. So this is, again, will be done automatically and automatically controlled through something we call it automatic voltage regulator, AVR. So AVR, it's automatically, it will be adjust the position and it will to maintain a stable output voltage under varying and load and supply conditions. Okay, so it will be automatically adjusted. Nobody will will do this. It's being programmed to maintain to maintain a constant voltage level. Here's how it looks like. The on-load, you see how is the turns ratio. This is the primary voltage side, this is the secondary, low voltage side. Then we can see this is the switch selector is here. If, for example, we need to decrease the turns ratio, go here, go to position 2, to 3, to 4, until 8. Then these positions, just like once, for example, if we are using position 8 connected here, then that's the turns ratio that you have. You will use only this one, while this one is neglected. Okay, so that's how the tap changer is working. Main tank, the main tank, or we call it the main frame, which is to carry the entire transformer, which is including the iron core, the winding, the insulation materials, which can be most likely the oil, which is manufactured in several shapes. We have the cylindrical shape, rectangular shape, elliptical shape, and it's designed to isolate the transformer from the external environment condition. It should handle the vibration, the internal pressure. It's also handle different weather conditions. It should be also, the main tank is made from steels, and it is, we need to make sure it should be capable to dissipate the heat generated by the electrical and magnetic coil, magnetic losses. It should be capable to handle the cooling oil as well. The capacity, higher capacity transformers that might contain oil circulation ducts or pipes forced for cooling. Because once we have the transformer size is depending on the power ratings. If you have a higher power ratings, will be higher sizes, bigger sizes. And we need to make sure it should be capable of handling the heats. The higher powers, there will be a high heats, very big heats. Here's how the main tanks looks like. So again, the function of it's protecting the core and windings, supporting the terminals and connection outlets, containing and preserving the transformer oil, carrying the radiator pipes in terms of in case of there's a radiator. This is from the distribution transformer. This is for the power transformer. Okay. The expansion, the conservator tank. Come on. This is the conservator tank. What's the point of using this? The conservator tank, it's filled with oil as well. It's just to provide a backup oil for that main tank. Why we need a backup oil for the main tank? Which is basically sometimes due to the weather, can be like in heats, the oil will be expanding. In weather, on cold days, the oil will be shrinking. So we need to have the conservator tank for that. For the expansion and the contraction due to the temperature changes. And it is basically the volume is 1/10 of the main tank. This is the rule of thumb. The functions of the conservator tank is to ensure the oil coverage, it's filled. We need to make sure the main tank is filled all of the time to minimize the oil exposed to the surface area and to preserve oil quality by decreasing the risk of oxidation and moisture, and to accommodate the oil expansion and contraction. That's also something very important by the temperature variation. This is the conservator tank. Again, it's located here. This is how it looks like. Again, it's 1/10 of the size of the transformer of the main tank. 1/10. Oil level indicator. Oil level indicator, which is very important for us, which can be here inside. I mean, a meter inside here. It should be here. Where is it? Let me see another picture for the conservator. Yes, here is it. Oil level indicator. So what's the point of using oil level indicator? It will tell you, like, where is the oil, if it is exceeding the maximum or below the minimum. What's the point of using this? Under normal operating, there's no problem, which is we need to make sure in monitoring, which is the oil is fine. But if there is a leakage or if there is too much oil, you will see it's at the max. So we just like to ensure the oil with the safe level. If there is, something wrong, then you can look at the oil level, then it will tell you there is leakage oil in the oil. The breather device. What does it mean, the breather device? The transformer can breathe like us. Wow, how? It's breathing, which is basically, it has inhalation and exhalation like us, breathing air. How can it breathe? Or what do I mean by breathe? There will be air volume inside it due to the temperature. The oil temperature can increase and can decrease. Once being increase and decrease, it can produce some gas bubbles. Those gas bubbles need to be exhaled. How to exhale those gas bubbles? By there should be a place to exhale. How can they be exhaled? Or we need to free up the free it through air breather device. But the thing, sometimes we need to have inhale. If, for example, like the temperature is getting reduced, then we need to have inhale. How to inhale it? Well, there should be some incoming air. But the problem is the oil, transformer oil, is sensitive to moisture and dust. Sensitive to moisture and dust, which means if there is a small particles of moisture, a small particle of dust, the insulation of the oil transformer will be reduced a lot, which will be very dangerous. It is very sensitive. So we must have a pure oil of the transformer. There is no particles on it. That's why the transformer oil is very expensive. We need to make sure it's pure. So how to pure it, the incoming air from dust and moisture, using the breather device. How can we see it? Using the silica gel. There should be a silica gel that will absorb the moisture. So the silica will absorb the moisture and the dust. Moisture and the dust. So again, the breather device, it can be how the shape looks like. It's a cylindrical shape or container, and it is a transparent, like from glass, so you can see what's inside it. You will see most likely silica gel that absorb the moisture and absorb the dust, and you will see it at the bottom of the cylinder, like it will carry or try to absorb the moisture. So most likely you will see it in blue, or there will be in the blue, or I would say like purple. But once being pinkish or in pink color, this means the silica is filled with humidity or moisture. So the breather device is, again, here is the main tank of the transformer. This is the power transformer. This is the other one, the auxiliary transformer or the zigzag transformer. This is the breather here in cylindrical shape. It's very small and cylindrical, and you will see it in the very at the bottom of the transformer, the bottom edge of the terminal here. Then you will see it in like purple color, or I would say like blue color. This means it is absorbing the moisture. Um, how or this silica gel must be replaced from time to time. So once being turned to be pink, which means pink filled with moisture. Once we reach 2/3 of the silica gel become saturated or become pink, then must be replaced. It must be replaced. So we just monitor this. We need to do regular maintenance or regular checkup to see if 2/3 of that container is pink, then we need to replace it. So we need to make sure it's not once being turned from blue to pink or from orange to green, which means in some situations, but the vast majority that we are using in Jordan, blue to pink. Blue, we are safe. Pink, no, we are in dangerous. 2/3 of pink, 2/3 pink, then replace it. Okay, I'm not sure. Do I have image picture for this? I do think we have for the silica gel, but just make sure. I mean, it's not pink. There's another thing is called Buchholz relay. On Arabic, we call it Buchholz. Buchholz relay, which is basically a relay that's used to determine the oil level or the oil level indicator. Oil level indicator. Okay, wait a minute. We already said that there's an oil level indicator here, right? Here is it. So what's the point of Buchholz relay since there's oil level indicator? So Buchholz relay, it's not only about the oil level, it's also about some warning faults happening inside the transformer. What do I mean by warning faults? Here is the Buchholz relay, how it looks like. There are two switches. If the oil level going down, the alarm stage will be turned on. If the oil level go to the next switch, here's number one, here's number two. Goes below that number two, trip will be turned off. The power will be turned off from the transformer, which means there's something dangerous. While this one, it will be alarm. Okay, but how the oil level will be decreased? It can be decreased because there is some faults or the oil liquid, there is a leaking in the oil, or if there is a fault, internal faults. Internal faults will cause a lot of heat in the oil. A lot of heat will cause bubbles. So what's happening? There will be some gas bubbles that pushing the oil down and the gas bubble goes up. Since the gas bubble goes up, then you will reach alarm stage, and after that reach the trigger states. So again, the upper float, which is connected to the mercury switch, which is closest contacts when the oil level drops slightly, but this is called, again, alarm stage. Alarm, which the control center, national control center, or the substation switchgear, you will see alarm stage. There's something wrong on transformer number one in Spahi substation, for example, so please check. So it's still in service. There's no power outage, but it will tell the power substation, the indication, warning indication. Then they will send the maintenance team to check, to make an inspection before something wrong happening. Then, if the problem continues without solving, then there will be the gas bubbles will be up, pushing the oil to be down. Once the oil goes down to the lower level, it will trip immediately. The power will be out on the transformer for protection. The transformer is very expensive equipment. It's in millions. So if there's something wrong happening in it, if it's being exploded, this will cost a lot of millions and it's very dangerous. It will damage the equipment, damage the switchgear, which will be something that we don't want. Therefore, the most expensive equipment in the substation is the transformer. The most dangerous equipment in the substation is the transformer. So if it's reached in this level, which means there is something serious there's something that we must solve it, then therefore it will trip automatically, then send the maintenance, solve the problem. After that, they will de-energize it. They will re-energize it. Where is the location of the Buchholz relay? Here. Here is the main tank, or here is the conservator tank, and here is the main tank. So it will be between them, and it is with the slope 3 to 7 degrees. Here is the conservator tank. Here is how it looks like, the Buchholz relay. Okay, where is the location? Let me show you a picture of the main tank, then we can determine where is the Buchholz relay. You see the main tank? This is the conservator. This is the main. Where is the Buchholz relay? In between them, and the pipelines between them. Here is it. Here is it. You see, this is the Buchholz relay. Let me see another picture. Show you another picture. Where is it? Sorry. I need to see a picture, a big picture for the power transformer. Here's the power transformer. I don't think we can see the Buchholz relay here. Not here as well. Maybe we can see it in the GSU transformer. Let's see at the beginning. The GSU transformers. Come on, where is it? I'm sorry, but I need just to show you a demonstration. Okay. Oh, I'm sorry. There is a technical issue. All right. Yes, so let's look at this picture, the pipelines. Yeah, here is it. This is the Buchholz relay, is located here. Here. This is the Buchholz relay, 3 to 7 degrees slope. And I believe here it is, yes, 3 to 7 degrees. So it will be between the conservator and the main tank, but most likely very close to the conservator tank. Let's go back to the Buchholz relay. So again, the Buchholz relay, when faults going on, there will be some gases begin to accumulate inside the Buchholz relay. So which causes the oil level to be decreasing. So you'll see here start some gases formation, then there will be more gases, more gases, more gases. So fault continues. Then more gases. Here it will be alarm stage because there will be more gases pushing it down. So in the alarm stage, when there's a more gas pushing it down, they will see a warning lights on the switch gear. You'll see warning, transformer 1. The same thing like there will be the warning, they will go also toward the national control center. National control center, they will see also the monitor, the control room. They will see TR1 in, for example, Sbahi substation. There is a warning. Then if the fault continues, I'm sorry, the fault continues, the gas keeps, the oil level keeps decreasing, the gas keeps decreasing until reaching this point, which will cause the trip stage. This is a trip stage. This is still warning. This is warning. While the trip stage, once this one's triggered out. Okay? So which is filled with gas bubbles. So you need to distinguish which one is tripping stage, which one is warning stage, which was in normal stage. Transformer oil. Now the transformer oil, which is the primary usage, is to insulate and cool the windings and the iron core. The oil level is monitored using the oil level indicator, which is the primary typically installed in the conservator tank. Again, it's for cooling and insulating for two purposes: insulate and cool. High quality oil must be. Otherwise, if there's some chemical impurities, if there is some moisture, dust, it will make chemical instability and lead to acids make deposit within the oil, and that can, the moisture, water, carbon impurities can reduce the dielectric strength and negatively impacts the insulation performance, which will be something undesired. Therefore, we must have a high quality transformer oil that's clean of impurities, clean of particles. Sorry. Cooling systems. Cooling systems in the transformers. The transformers, there are two types of the cooling, which is the dry type transformers or oil immersed transformers. If it's the dry, then normal air will be using coil. If it is oil immersed, which will be basically the what there will be oil to cool it down. The dry type transformer are very rare and it's used in small capacity transformers. However, the vast majority that we have are oil. So this is the vast majority here for which is called the oil transformer. Then the next thing is the, as I said, like the oil transformer that's used for medium and large capacities. We have different type of coolings. There is called air natural for air, which is called again like air dry or the dry. There is no oil, so which is called air natural cooling. There is air forced. What do you mean by air force? Which is basically using fans to cool it down. Now, the other thing that we have, if there's oil immersed, if it is oil immersed, there is called oil natural, air forced. I'm sorry, air natural. So, which means there is no fans, which is the same thing that we used to have in distribution transformers in Jordan. This is oil on it. Okay, the next thing, there is ONAF, oil natural, air forced. This is used also in Jordan for power transformers, and also ONAN also is used in power transformers. And there is OFF, oil forced, air forced. Oil forced, there should be an oil pump that's used to circulate and to cool the oil. There should be a radiator as well for cooling it down. There is ONAF, often oil forced, air natural. This is very rare. And there is oil natural, water forced. Sometimes the fan is not enough, then we need to put water circulation. And there is oil forced, water forced. This is also very common. But the one that we have in Jordan, the vast majority of the transformers are ONAM. While we have ONAF that exists in 132 kilovolts, some of them, and in 400 kilovolts levels, like 132 to 33, or 132 to 400 kilovolt to 132 kilovolts. The other thing in Jordan as well, there is ONWF. But it's not 100% ONWF. We are using it manually in 400 kilovolts to 132 kilovolts. It's used only during summer, manually during summer, during hot days in summer. Okay, so you need to distinguish what does ONAN mean, what does ONAF mean, what does OFAN and OFF, ONWF, OFWF, A and AF. So it's very important for you to know the difference between all of them. Again, the first letter of designations. So the first thing, O for mineral oils, K for synthetic liquids, L for non-mineral oils, second letter for oil circulation method, N for natural, F for force, D for dielectric, third letter for type of external cooling, which is A for air, W for water, and fourth letter for a cooling medium, which is natural or forced. We already mentioned this. So air natural again for dry type, and which is normal air, there is no cooling fan. Air forced, dry type, but there is a cooling fans for cooling it down. Now, ONAN, again, it's used to up to 30 megavolt ampere for cool, which is used in power transformer and distribution transformer as well. Oil natural air force, this is used between 30 to 75 megavolts ampere. This is used in Jordan in power transformer, again 132 kilovolts to 33 kilovolts. This is very rare in here, but the vast majority, I would say, is used in 400 kilovolts to 132 kilovolts. That's where we are using it. While oil forced air force, this is not in Jordan, but it's 100 megavolts ampere. We don't have it in Jordan, but again, where we can use it for, I mean, it's outside of Jordan when we have 100 megavolt ampere. Then the other thing, temperature.
ان ينتهي من 3 مواد من دور ال 16 ولا فريق وكملتها الخروج من الملحق لكاس العالم مستوى كارثي الله يحسن
Please close your mic.
دوريهم جميل برجع بقول اجمل القمم هذا الموسم تجدها في الدوري الايطالي وعلى فكره ايطاليا خرجت على ايد البوسنه والبوسنه دي الرجال الاسلاميه وتستحق التواجد في المونديال ولعب
لا اله الا الله. Okay. تمام deal. Okay, let's keep going. Sorry for that confusion. There was somebody. Please turn off your mic. Thank you. Temperature measuring devices and transformers. We have the temperature meter. So the temperature, we need to make sure to measure the temperature for two things, the winding temperature and the oil temperature. So we have two types or two measurements for the temperature to make sure there is the transformer will not explode, or we don't want the transformer to reach a high level. Now, let's stop here at the transformer protection. We will continue, inshallah, next lecture. So for the transformer protection. So that's it for today. Let me recording. Just give me a sec.